Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. Bredt's rule and ring strain at bridgehead junctures. When three rings meet at a single carbon atom, a bridgehead, the geometry imposed by the rings determines how far the bonds at that atom deviate from the ideal tetrahedral arrangement. Planarity here refers to the tendency of the bridgehead carbon to be forced toward a planar, sp2-like geometry, or more generally, the degree of angle strain and distortion. Part A. Greatest deviation from planarity. Moving on to the next step. Identify ring sizes at each juncture. Atom A, junction of three 6-membered rings, 6-6-6. This is a relatively relaxed system. 6-membered rings are flexible and can adopt chair conformations. The bridgehead is not highly strained. Atom B, junction of three 6-membered rings, 6-6-6. Similar analysis to the system is relatively unstrained. Atom C, junction of a 6-membered ring, a 4-membered ring, and a 5-membered ring, 6-5-4. The 4-membered ring introduces severe angle strain, internal angles tilde 90 degree, forcing the bonds at atom C into highly compressed geometry. The combination of a strained 4-membered ring with larger rings at the same bridgehead creates the greatest geometric distortion. Moving on to the next step. Compare strains. 6-6-6 junctures, A and B, are comparatively strain-free because 6-membered rings are low strain. 6-5-4 juncture, C, is the most strained because the 4-membered ring demands tilde 90 degree bond angles, severely deviating from the ideal tetrahedral tilde 109.5 degree. This causes the greatest deviation from planarity at the bridgehead. And for the final step. Why A and B fail? Both A and B are 6-6-6 systems with similar, low strain. Neither has a small ring to impose severe distortion. Answer to A, C. Part B, most favorable site for H2 addition. H2 addition to a C bond in a polycyclic system, hydrogenation, is most favorable at the bond under the greatest strain because relief of strain provides the greatest thermodynamic driving force. Identify the bonds. Bond 1, a bond in the 6-6-6 system at juncture A, part of 6-membered rings, low strain. Bond 2, another bond in the 6-6-6 system at juncture A, similarly low strain. Bond 3, a bond in the 6-6-6 system at juncture B, low strain. Bond 4, a bond at juncture C, specifically the bond shared between the 4-membered ring and the adjacent ring. This bond is part of the highly strained 6-5-4 system. Breaking adding across bond 4, the bond of the 4-membered ring, relieves the maximum ring strain. The 4-membered ring bond 4, is the most strained. H2 addition, hydrogenolysis hydrogenation of the strained C bond across bond 4 would open the 4-membered ring, providing the greatest relief of strain and thus is the most thermodynamically favorable. Why 1, 2, 3 fail? Bonds 1, 2, and 3 are all in 6-membered ring systems with minimal strain. H2 addition there provides little strain relief and is less favorable. Answer to B, D, 4. Therefore, the correct answer is A, C, B, D. Therefore, the correct matching is A matches C, B matches D.